Okay, here's a College Board macro free response question that's a nice follow-up to this handout that I posted under downloads. The handout's called Price Indices, and it goes through a lot of things, but the basic takeaway is that when you're computing real GDP, you fix the price and change the quantity. And when you're computing a price index, you fix the quantity and change the price. In the first case, by fixing the price and allowing the output to change, you get a pure measure of output, which is you want for real GDP. That's not um, affected at all by changes in prices. In the second case, you're not really so concerned about what you're buying as what price changes you're seeing. So you fix the basket and get a pure change in price that's unaffected by changes in quantity. So we're always going to be computing for this problem the value of the basket, which is always going to be, you take the apples, you take the price times the quantity of the apples, and then there's the oranges, and the price times the quantity of the oranges, and you add these things together and you get a total value for the collection. That's the basis of all the calculations. What's going to change is what we use for price and quantity in each case. And I've circled all the year one prices and quantities in purple and the year two quantities in green, so we can easily distinguish. The first thing we're asked for is the nominal GDP for year two. And the nominal GDP for year two is easy. A nominal just means use all the current year prices and quantities. So it's 6 and 10 for apples and 5 and 20 for oranges. And then next we're going to be asked to compute the real GDP for year two. So to compute the real GDP for year two, I use the year two quantities, just like I did before, 10 and 20, but I use the base year prices. We fix the prices to the base year, so we get a pure measure of output change. So the base year price of apples is 4, and the base year price of oranges is 10. And then we multiply and add across both of these collections. So we have 60 plus 100 is 160 for the total value for a nominal, and here we have 40 plus 200, or 240 for the real GDP. And then to find the GDP deflator, always, we just take the nominal value for the year, divide it by the real value for the year, and multiply by 100. So in this case, we take the nominal GDP, which is 160, divide it by the nominal, which is 240, and multiply by 100. And this gives you roughly, this is 80 goes into there twice, goes into here 3 times. So it's 2/3 of 100, which is 67 rounded to the nearest whole number. So there's my nominal for year two, real for year two, and my GDP deflator for year two. Notice that in as far as the GDP deflator is concerned, we've seen deflation. The price level actually is lower in year two than it is in year one, and that's because of the big price change in oranges kind of dominates the calculation here. The price of oranges decreased by half, and there are an awful lot of oranges in the second year. We made 20 oranges in the second year, so this quantity and this price change really dominate here for oranges. And since oranges are less expensive in year two, the GDP deflator suggests that we've seen deflation. See a different picture here when we go down and look at the price index. So part D says compute the CPI for year two. So to compute the CPI for year two, we need the year one value and the year two value both computed according to the market basket, which we're told is what was produced in year one. So the market basket is consistent. The market basket consists of 15 apples and 4 oranges. That's going to be the same for both years, 15 and 4. This is the year one sum, year one value, and this is the year two value. So the basket stays the same. What we allow to change is the price. So in year one, we use the year one price, which is 4 for apples and 10 for oranges. And for year two, we use the year two prices, which are 6 and 5. So the prices have changed, quantity stays the same. That's what happens when you're computing a price index. So we multiply again and add. Our first sum is 60 plus 40 is 100, conveniently. And this one is 90 plus 20 is 110. So the CPI in year 2 is the total value of the basket in year 2, which is 110, divided by the base year value of the basket times 100. And because they conveniently had the base year basket value as 100, that multiplication by 100 makes the computation trivial. This isn't always going to be 100, but in this case it is, so that made it easy. The value of the market basket in the base year doesn't have to be 100, but it just was in this case. Notice that this says 10% inflation. This is 10% inflation, whereas this was deflation by a third, right? So this is 33% deflation. And the reason that they're different is because this guy up here, when we computed the real GDP, the difference was dominated by the big collection of oranges. We had 20 oranges in the market basket in year 2, or was produced in year 2, and the oranges decreased in price. Down here, when we're looking at the price index, we're basing it on the market basket in year 1. There were only 4 oranges produced in that year. So even though the total value of total cost of oranges dropped from 40 in year 1 to 20 in year 2, it's this change in apples that dominates, because that 50% price increase in apples dominates because there's so many more apples produced in year 1 than there were oranges in year 1. So you get a different measure of inflation depending on what's in the market basket, which is why it's so important. It can make a big difference what's in your market basket as to whether you measure inflation or deflation. All right, finally we're asked to look at the what happens to real wages for the pickers, and the answer is that the real wages decrease because their purchasing power goes up by 2%. We're told they have a 2% increase in wages, but prices in goods and services go up by 10%, just 10% inflation from year 1 to year 2, according to the CPI in D, which we're told to use. So overall, their purchasing power has declined. The income that they earn in year 2 doesn't buy as much as it bought in year 1.